Hey everyone, I'm Faden. Welcome back to Solid Principle series. Today we're talking about the principle that's basically telling your classes, hey, don't try to be everything for everyone. That's right. We're diving into the Interface Segregation Principle, or ISP. Now, I know interface segregation sounds like something from a corporate HR manual, but don't worry, it's way cooler than that. This principle is all about giving your classes only the tools they actually need and not forcing them to implement stuff they'll never use. If you've ever had to fake a function just to satisfy an interface, this video is for you. Let's break it down and see how ISP helps you build cleaner, smarter, and more respectful code. Here's the official definition of the interface segregation principle. A client should not be forced to depend on methods it does not use. Sounds serious, right? Okay, let me explain that in normal people language. Basically, if you're building a class and it needs to follow some interface, you shouldn't have to implement a bunch of stuff that has nothing to do with what your class actually does. It's like forcing a penguin to take flying lessons just because it's technically a bird. The interface segregation principle says, let each class do what it's meant to do and don't force it to pretend to be something it's not. This makes your code simpler, easier to maintain, and honestly, just more respectful. So, why does the interface segregation principle matter? Well, first, it helps you avoid creating these massive bloated interfaces that try to do everything. You know the ones, 20 methods, and your class only needs 2 of them. Second, it keeps your classes clean and focused. Each class only depends on the methods it actually needs, which makes your code easier to read and easier to change. And finally, it saves you from writing those awkward fake methods. You've probably done this before. You had to implement some function just to satisfy an interface, but you end up leaving it empty or worse, throwing a not implemented error. ISP helps you design smarter interfaces so your class never have to pretend. Let me give you a real-world way to think about the interface segregation principle. This here is a Swiss Army knife. It's got everything. A saw, a knife, a can opener, a bottle opener, a screwdriver, a corkscrew, and oh yeah, somewhere in there, scissors. Now imagine you just need to cut something. Do you really want to carry all of this around just to use that one tiny pair of scissors? Right here. These scissors, that's the only tool you care about, but you're still dragging around all this other stuff that you don't need and probably won't use. That's what happens when a class is forced to implement a huge interface with methods it doesn't actually care about. It becomes bloated, awkward, and hard to maintain. Now this is what you really need. It's simple, it's clean, it does the job. No unnecessary extras, no clutter. And that's exactly what ISP is all about. Don't force your classes to carry a whole Swiss Army knife when all they really need is a pair of scissors. Alright, let's take a look at a bad example that clearly breaks the interface segregation principle. Here we've got an interface called worker. Seems simple, it has 2 functions, work and eat. Now check out this class, robot. It implements worker, so it's forced to define both of those methods. The work function makes sense, the robot works non-stop, no problem there. But then we hit the eat function, and what does that robot do? It throws an error because, well, robots don't eat. This is exactly what the interface segregation principle warns us about. The robot class is being forced to depend on a method it doesn't need, and that leads to messy, confusing, and even dangerous code. Now let's fix the previous mess by following the interface segregation principle properly. We start by splitting the big worker interface into 2 smaller ones, workable and eatable. That way we can be more precise, classes only implement the functionality they actually need. Now take a look at the human class. It implements both interfaces because human can work and eat, so no problem there. And here's the best part, the robot class. It only implements workable and completely ignores eatable. No fake methods, no errors, no pretending to eat batteries. This is exactly what the interface segregation principle is all about. Smaller, focused interfaces that don't force classes to take on responsibilities they don't need. Let's quickly go over why following the interface segregation principle is a big win. First, it keeps your interfaces small and focused. No bloated, do-everything interfaces, just clean, specific contracts. Second, it makes your classes way easier to build and maintain. You only implement the methods you actually need, so there's less to manage and less to break. And finally, it reduces bugs. No more weird placeholder methods, no more throwing errors just to keep an interface happy. You get cleaner, more reliable code and fewer surprises down the line. And that's it for the interface segregation principle. We looked at why it's important to design interfaces that are focused and minimal, so our classes don't get stuck with methods they don't need or can't actually use. It's a simple principle, but it makes a big difference when it comes to writing clean and maintainable code. I've added the full code examples on GitHub. You'll find the link in the description if you want to explore it more or try it out yourself. If this video helped you understand ISP a bit better, go ahead and give it a like, leave a comment with your thoughts or questions, and hit subscribe if you haven't already. We've got one more solid principle coming your way. Next up, the dependency inversion principle, and trust me, that one's going to blow your mind just a little. Thanks for watching, and I'll see you in the next one.